Solve linear systems by graphing. The problem says solve the linear systems graphically. Check your solution. Equations are y equals to x plus 1 and y equals to 5 minus x. As you know, we can solve linear systems graphically or algebraically, correct? So in graphically, what we should do is we should just sketch the graph of these lines, and wherever they intersect, the point of intersection is the solution of the linear system, right? Now you can graph these lines making table of values, that's one way. Second is you can use slope and intercept to find the graph or to sketch the line. In this particular, because the equation given to us is in slope and intercept form, so best thing is to graph it using slope and intercept, right? So let's go for the line 1. Y equals to x plus 1. Now here, what is the y-intercept? So y-intercept is when x equals to 0, right? When x equals to 0, y equals to 1. So y-intercept is 1. So we get that point. Now what is the slope? Slope is coefficient of x, which is also 1 here, right? So we can have points. Rise over run is slope, right? So rise and run, we get 1 point. Rise and run, we get 1 more. Like this, we can go minus 1 and minus 1. That will also give me 1, right? Minus 1 is the rise and minus 1 is the run. So that gives me slope. The new points are drawn, finding slope, right? So we can now join these points to get our first line. So graphical solutions are not very accurate, so try to do your best when you draw these lines. Okay. So we have used this color for this equation. Okay. Now for the second line, let's use a different color. Let's say blue. Now here, what is the y-intercept? Y-intercept is 5. 1, 2, 3, 4, 5. So there we are. That's 5. And slope is minus 1, right? Minus 1 slope means you go down. That means either you can take rise as negative or run. So we'll take rise as negative, which is going down, and 1. So that is minus 1 slope, right? And that's the point of intersection, right? Rise over run. So we get a point of intersection along with our line here. And let's join these points. Correct? This is our line number 2. We can write down the equation. It's better to write the equation of the line here itself so that you know which line represents which equation. So y equals to 5 minus x is this blue line. And the other line is y equals to x plus 1, correct? And the point where they intersect is our solution. That's the point. And this point is 2, 1, 2, 3. Okay? So that's the point of intersection. And we'll write this here as the solution, right? 2, 3. Now, graphically, we got x coordinate as 2 and y coordinate as 3 as a solution to this linear system. Now, to check this solution, what we can do is we can use both the equations one by one. If I plug in 2 for x, I should get y value as 3. So in the first one, you know, y equals 2. If I plug in 2 for x, I get 2 plus 1, it is 3, right? So the point is correct, 2 and 3. In the second equation, we can do the same thing. We'll have 5 minus x value of 2 will give us y value of 3. Therefore, 2, 3 is solution, right? To our linear system. I hope you understand how we have sketched the graph and found the point. Okay, this one, because the point is 2, 3, no decimal places involved, so this graphical solution is pretty accurate, right? Okay, And it's good practice to write, label your axis. Okay, so that's how we do it. Okay, thank you.